That is the next video that I made for you. This is actually about mole concept and how to use that mole concept for several way in the stoichiometry. Okay, welcome back with hi, Mr. Oni. Hi. Okay, let's start it. Okay, first we will learn about AR and MR. AR is the relative mass of an atom toward carbon-12. So the mass of atom that compare with carbon-12. Why with carbon-12? Because it's very stable. Rather than hydrogen. Hydrogen is not stable. So we use carbon-12. Yeah. This will be measured, the mass will be measured by using mass spectrometer. Before it, you can think, what is the difference between weight and mass? Okay, you should know it in the physics before. Okay, the unit of the R or MR later on, it's atomic mass unit, AMU. Yeah, so for carbon, its atomic mass is 12. So you can imagine it because the thing that we can measure the weight is the proton and neutron because the electron weight is negligible. Okay, you know what is the mean of negligible? We can neglect it because it's very light. Okay, so the AR is the average mass of naturally occurring atom of an element on a scale. Okay, for example, the very worst one, chlorine. Chlorine atomic mass is 35.5 for one atom, for one single atom. Why? Because chlorine actually have two isotopes. Do you remember what isotope is? Isotope is the atom that have same amount of proton but different amount of neutron. There is a relative abundance of chlorine 35. It's around 75% that present in the world, in the earth, while chlorine 37, which have 17 proton and 20 neutron, it's around 25%. So we can calculate it like this, and we will have the amount here. So therefore, the AR of Cl, chlorine, is 35.5. Okay, the next one. If we do with MR, MR is the relative atomic mass of one compound. So you have to summarize adding the amount of its atom. For example, here, H2O. H, we know the R is 1. You can see it in periodic table. You can see it in the atomic mass. Actually, in the periodic table, there is atomic mass. Yeah, and R of O is 16. So if you want to measure H2O, RH is 1. So there is 2 H. So you times 2 times 1, 2. And then 1 O, 1 times 16 is 16. So the molecular mass or MR of S2O is 18. Okay, 2 plus 16. How about if we have hydrated salt? Hydrated mean contain water. So one copper sulfate here will consist of 5 molecule of water. So in this case, you have to measure AR of Cu. Copper, you can see on your periodic table, AR of S, AR of O here, and AR of H. Yeah, so calculate it. How many copper here? 1. 1 times 64. How many silver here? 1. 1 times 32. How many oxygen here? 4 plus 5 times 1. 9. 9 times 16. How many? It's 2. It's here, hydrogen. 2 times 5. 2 times 5, 10. Times 1. So you calculate it. So the MR of COS copper sulfate, hydrated copper sulfate is 253 mR. Okay. Okay. This is an example. For example, we have calcium hydroxide. This is the name, right? If you have learned it in naming compound, calcium is the metal, and this one OH is hydroxide. Okay, so we should see in the periodic table first. AR of Ca is 40. Huh? AR of O is oxygen is 16. AR of H is 1. Okay, so for this one, because only one each, it will be very easy. So you just add 40 plus 16. Okay, this is 16, I mean. And then plus 1. Okay, use your calculator to calculate it. So this one is 57. At first. Okay, back. We will do balancing equation. Mr. Oni is ready to do balancing equation. Yay! Okay. For balancing equation, you should know that the component of equation. In chemical equation, you will have reactant. We will use this one. Okay. Reactant in the left side and product in the right side. Okay, so this one I will annotate it. This one is the reactants. Okay, I cannot write it here. Okay, this is the product. Yeah, and it should be balanced between left and right. This one is called coefficient. Yeah, this one is called coefficient. Okay, for the balancing equation there is state. For example, this one you maybe see it K. It's a stand of gas, and then you can see it. For example, L. It is stand from liquid, and so on. That is the component of the equation. I will back to my slide here. Okay, this is the component. Reactant is the left side, product is the right side. The result. And between the reactant and the product, the amount of atom should be remain the same. Okay, that is the state of the reactant and product are for this one. G is gas, S is solid, L is liquid, Aq is aqueous. What does aqueous mean? It can be liquefied by dissolving it into water. For example, sodium chloride. If I write it Aq, the sodium chloride is dissolving in water. And also it can be melting down. For example, the same sodium chloride that I heat up until it melts, it's called aqueous also. Yeah. And then the coefficient, that is the number in front of each compound, it's inserted to balance the equation, to make it the same amount of atom between the left and the right side. Okay, this is the example. For example, we have methane. Methane is CH4. We have oxygen, and the result, if you burning methane, you will get carbon dioxide and water. Okay. For example, if I not yet give you this one, yeah, you need to balance it. So you have to know that it's in the left side, in the reactant one, here reactant, and here is the products, yeah. Okay, The carbon in the left side is 1, and the carbon in the right side is also 1. So it feels like it's already balanced, right? And then the next one, you have to calculate the hydrogen. Hydrogen in the left side is 4, while hydrogen in the right side is only 2. So you have to times it 2 for make it balance. So therefore this one is 2. Okay. And then the oxygen also. The oxygen in the left side is 2. But because we have already times it, this one with 2, so this one is 2. And also we have it in carbon dioxide 2. So it's not balanced, right? We need to times it 2. Yeah, 2 times 2 is 4. So you have 4 oxygen in the left side and 4 oxygen in the right side. That is how we can balance the equation. We will have a lot of practice so you can understand it. And I will give you homework also for this one. Okay, so you can understand this one. This is reactant, this is the product. The amount of each atom in between reactant and product should be still the same. And then this is the coefficient, the yellow one, and this is the states. Okay, green is the state, brown is the coefficient. Okay. Okay. Actually, I forgot to mention that this one, CaH4 plus 2O2 equal to CO2 plus 2H2O. It's called the equation, chemical equation. This one is called methane plus oxygen will be carbon dioxide plus water is called word equation. Okay. The next example is for organic compound. Actually, this one, C6H5, it's benzoic acid, but you don't need to write the word equation. Any organic compound that you combust it means you react with oxygen, will create carbon dioxide and water. So in this one, actually, we will try to balance it. This is organic compound. So there is several tips for organic compound. The first one, you have to balance the carbon. So here is carbon. There is 6 carbon and 1 in the reactant. And also this one is only 1 carbon. Okay. So 6 plus 1 is 7, right? So we have 2 times it 7. Okay. This is the first one. And the second one, the tip is you balance the hydrogen. Okay. Hydrogen in the reactant is 5 plus 1, 6. Yeah. Hydrogen in here is only 2. Is it balanced? For sure, nah. 6 and 2. How you can make it balance? You have to times it by 3. Yeah, so this one is 6. Okay. It's already balanced. How about the oxygen? The oxygen here, I will like imagine it as B. Yeah. So you have in the reactant 2 oxygen plus 2 B, because this one 2 times B. Okay. And then here you have 2 times 7 plus 3 times 1. Okay. You calculate it. 2 plus 7 is 14 plus 3. So it will be 17. Yeah. This one is 2 plus 2b, 2 plus 2b. And then it's a balance for sure. Nah. So 2b, 17 minus 2. 2b is equal to 15. Can you have, so b is 7.5. Can you have it? If it's 7.5, I can replace this b with 7.5. But in balancing equation, you will not never give it into point. So you have times it 2 for all of this reaction. So the answer is here, because we times it till 2, so the answer is 2, 6, let's say 685 COOH plus 7.5 times 2 is 15. 15 oxygen here equal to, yeah, this is 1 is times 2. 7.2 is 14 CO2 plus 3 times 2 is 6. 6 H2O. Yeah. So this is the answer. Okay. You need practice in balancing equations, so I will give you several example later as your homework. Sometimes there is not only 2 reactant and 2 product. It can be more than 2 reactant and product. Okay. Okay, Ami, we will do one more example. All right. All right. Okay. This is a very complex equation, consists of 2 reactants and 4 products. First, I will do the word equation first, after the chemical equation. For the word equation, actually, you don't need to put the coefficients. So, this one is potassium permanganate. It's actually, you need to remember the name because it's not too common. Permanganate plus this one, hydrochloric acid. This is a common one. Okay, it will create the product potassium chloride and this one is manganese 1 chloride. This is actually also transition metal, so therefore, manganese 2 chloride. There, I put the brackets with Roman's number, water, and chlorine gas. This is, I will put also, okay, I will back to my pen before. I will also write here, aqueous. This one is also aqueous, liquid, and gas. Okay, to balance this one, we need to use the algebraic one. We call, in bahasa, we call it rumus ABC. Because I will put here A, B, C, D, E, F. Yeah. Okay. First one, we will put K, potassium. Yeah. First, if we work with potassium, I will use this one. Potassium is A in the reactant equal to C in the product. Yeah. And then Mn. Mn is A in the reactant and D in the product. It's not same not to equal, right? Later we will do it. Okay. Then oxygen. Oxygen is 4A in the reactant and where is it? A plus, oh, there is no more. Yeah, so only A in the product. Okay, we have Cl that very yeah. In the reactant, C is sorry, we will do hydrogen first. Hydrogen in the reactant is B. Then in the product is 2A. There is no more hydrogen in this one. For Cl, there is a lot of in product, is B in the reactant, and C plus 2D plus, I forgot F, yeah, 2F. Okay, I mean this is too little bit like, okay. Okay, we will make example here. We will make example here. For example, this one is all 1 because A equal to C equal to D here, right? So I will replace it with 1, 1. Sorry. 1 in A, 1 in C, 1 in D, and then, for example, as if I work on with this, so 4 times A equal to E. So E is 4 here. Where is E? Okay, and then B. B is 2A. So therefore, B is 8 here. And then I will work on this one. 8 is equal to C1 plus 2 times 1 plus 2F. Because we will not know yet the F. So this one is 1 plus 2 plus 2F is equals 8 plus 3 plus 2F. So 5 is 2F. So if I move my fish here, okay, F is 5 per 2. Because we cannot put per, if it's per, so we have to times it all with 2. Yeah. So in this equation, we need to times 2, all of the equation. So therefore, the conclusion is this one is 2, this one is 16, this one is 2, this one is 2, this one is 8, and this one is 5, because 5 per 2. Okay, we have already got the example, the question, the answer. I will repeat it in the other page here. 2, 16, 2, 16, then 2, 2, 8, and 5. 2, 2, 8, and 5. This is the final equation from this algebraic structure. Here, you can follow this step by step. So for it, you have to make estimation here by using A, B, C, D, E, and F for its coefficient. Then you need to replace one by one. For example, this one, first I replace it by 1, and then I calculate one by one like this one. And then because in the end I got 5 per 2, I have to times 2 all the equation. So there is no fraction in the question in the answer. Okay, this is how we can balance it by using algebraic structure. That is all for the balancing equation. You need to do your homework. I will give you homework by using several number, and I will also give you worksheet. The worksheet, I will give you question from my own, and the homework is taken from the textbook, page 65 and 71. I will upload it into the LMS later on. Check the LMS and also check my YouTube channel so you can do it properly and collect it next week for the homework in your notebook, and actually for your worksheet and for the previous homework, you need to take a photograph and upload it into LMS because we are currently is online. So bye bye.